All right, let's jump right into this explainer. Today, we're unlocking something incredibly cool, how we can use math and tech to literally model reality, make predictions, and even shape our life choices. We are exploring the immense power of quadratic regression. Now, I know that phrase might sound like a bunch of heavy textbook jargon, but I promise you, it's actually one of the most practical, real-world tools you can have in your toolkit for making sense of the world around you.
Now, to kick things off, we've got this ultimate guiding principle for today. But test everything, hold fast what is good. Just like we should in our daily lives, we are going to use some incredible math tools to test out different numerical patterns, and ultimately, hold on to the one that fits the absolute best. It's actually a really beautiful parallel between how we navigate the world morally and how we solve complex data problems. Here is a quick look at our roadmap for today. We'll start with the messy real world, move on to what quadratic regression actually is, see how tech saves the day, look at some real-world parabolas, give you a chance to test it out, and wrap up with how education meets biblical morality. Okay, let's get into it.
Section 1. The messy real world and why perfect numbers don't always exist.
So look, in the real world, whether you're a scientist, a CEO, or an athlete, the data you collect is pretty much never perfect. We're all used to those squeaky clean textbook math problems, where everything perfectly lines up. But out there, the real world throws these scattered, unpredictable data points right at you. If you're tracking the flight of a baseball or forecasting revenue for a startup, those numbers aren't going to form a pristine, straight line. We need a way to make sense of the mess, right?
Which brings us to Section 2. What is quadratic regression? Basically, finding the best fit. So, how do we actually handle all that unpredictable information? Well, that's where quadratic regression steps in. It's really just a statistical way of asking, hey, what kind of parabola fits this messy data the best? Think of it like a mathematical detective. It sifts through all your scattered points to find that one specific curve that comes closest to connecting them all. And once we find that best-fitting curve, boom, we can suddenly predict future values, analyze trends, and figure out what the raw data is actually trying to tell us.
And here is the foundational formula we're hunting for. Y equals ax squared plus bx plus c. Now look, I know what you might be thinking. Staring at those A, B, and C puzzle pieces might feel a little overwhelming, but seriously, don't sweat it. You are not going to have to calculate those variables by hand.
Because of Section 3. Technology to the rescue. We're letting the calculator do the heavy lifting here.
Technology is absolutely your ultimate sidekick when it comes to testing this data. If you're using tools like Desmos, a TI-84, or even just Excel, the process is incredibly simple. Just 3 steps. First, input your data points into the software. Second, select QuadReg, that's quadratic regression from the menu. And third, just sit back and let the software crunch the exact values for A, B, and C for you. It literally does all the hard work, so you can test the data to find that perfect equation without getting completely bogged down in manual math.
All right, Section 4. Real-world parabola examples. We're talking sports, business, and roller coasters.
This is where it gets really fun. To prove how ridiculously useful this tool is, let's look at 3 rapid-fire examples of how this plays out in the wild, starting with sports. Imagine you're tracking the height of a kicked soccer ball every single second. At 0 seconds, it's at 0 feet. 1 second in, it's at 10 feet. At 2 seconds, it's up to 16, and so on. So you've got these exact, somewhat scattered data points sitting there on your screen. Just looking at the raw table of numbers, it's pretty tough to visualize the entire arc of the ball, isn't it?
But if you feed that exact table into your calculator and run a quadratic regression, you get this absolutely beautiful best fit equation. Y equals -1x squared plus 6x. And that is a total game changer. Now you can just plug in any time value for x, say 2.5 seconds, and predict exactly where that ball is going to be, or figure out the exact moment it's going to hit the dirt.
Okay, let's pivot for a second. Imagine you're a business owner. You're tracking your profits over 5 months. Month 1, you're at $200. Month 2, $350. Month 3 peaks at $400, but then it dips back down. Classic, messy, real-world business data. How on earth do we model that kind of up and down cycle?
Well, we test the data. Running this through our regression software spits out this equation. Y equals -50x squared plus 300x minus 50. Having this mathematical model is huge. It instantly shows you that your peak profit hits perfectly at month 3. In math terms, we call that peak the vertex. For a business leader, knowing your exact vertex is absolutely crucial for planning ahead.
Let's do one more. Engineering. Say a team of engineers is mapping out the track for a terrifying roller coaster hill. They've got these 5 highly specific data points marking exactly where that track needs to exist in physical space, represented by these X and Y coordinates.
They plug it in, run the regression, and get this highly precise model. Y equals negative 2x squared plus 8x. And look, this isn't just a fun math exercise. This is literally about keeping people safe. This equation tells the engineers exactly how high the hill gets and where the curve starts and stops. It ensures the physical track aligns perfectly with the laws of gravity and momentum.
Moving right along to Section 5, your turn to test. It's time to put these tools into practice. Now that you've seen how powerful this is across completely different industries, it's your turn to get hands-on. Here's a homework challenge straight from our source material. Grab your calculator or fire up Desmos and try running these regressions yourself. You're going to model everything from a car's braking distance to changing population data. And as you're working through these, I really want you to focus on that last point. Think about what the vertex, that highest or lowest point of your parabola, actually means in the real-world context of these scenarios.
Finally, Section 6, Education meets Biblical Morality, holding fast to what is good.
As you work through these mathematical models, it's worth thinking about how this concept of testing for the best fit connects directly to life itself. We use this amazing tech and these complex equations to find the absolute best models for business, sports, and engineering. But it naturally leads to a much deeper question. What is the real point of being smart and highly educated if we just continue to make bad choices that hurt us? And that brings us to the core philosophy of the Heroes Smart Academy Godly Learners series. The idea here is simple but profound. Gathering up all this raw intelligence and computational skill without holding fast to morality ultimately leads to harm. True learning has to intertwine biblical morality with education. Think about it. You wouldn't build a roller coaster without a reliable equation to ensure everyone stays safe, right? So why would you build your life without a reliable moral framework?
So I want to leave you with this final thought. The source text points to Romans chapter 8, verses 6 through 7, which promises peace of mind to everyone who keeps their mind spiritual. As you step out into the world to test everything, whether you're analyzing complex data sets or making major life decisions, to hold fast to what is good, how will you use that promise of peace to guide your next big choice? Keep testing the data, keep learning, and we'll catch you in the next explainer.